Good morning, everyone. Good morning to all, guys. So, friends, how are you? Please join fast. Okay. So, friends, I'm your friend Aishwarya Sharma, expert in GATE, ESE, and SSCJ. And friend, I have completed my MTech from IIT Delhi and BTech from Jamia Millia Islamia. 4 times I have qualified GATE with my best AIR 226. I do have 6+ years of teaching experience and 2 years of industrial experience. So friends, I'm going to take your these civil engineering subjects, which includes theory of structures, RCC, and geotechnical engineering. And it is our team. It is our team. So he is Abhishek sir, Chetan sir, Kshitiz sir, Nitesh sir, Babulal sir, Mrigang sir, Avinash sir, and it's me, Aishwarya. Is it clear? So guys, please join fast. Please join, all of you. Please join fast. Okay. So this is the schedule. This is the schedule of June. So whatever I have marked by green, these are the ongoing subjects. The top two are in English language, means SOM and RCC is going on in English mode, and environmental engineering and transportation engineering is going on in Hindi mode, evening batch, and these three batches are for SSC. They are for SSC. So guys, these 7 subjects are ongoing for you guys exclusively. Is it clear? So on the name of this thing, please like and subscribe the session. All of you, please like and subscribe the session. So where are you now? Okay. So welcome to lecture number 29. So it's about torsion. It's about torsion. Good morning, Rohan. Please like the session. Okay. So we'll continue with this torsion. So yesterday we have seen the various design procedures which were including 4 steps. What were the 4 steps? I think I have covered 3 of them, 2 of them, and third one partially, not fully. So first one was calculation of equivalent shear. Second one, calculation of longitudinal reinforcement, and the third one is calculation of transverse reinforcement. So like this. And fourth step which we are going to study today, it is side face reinforcement. It is side face reinforcement. So any doubt till here to anyone? Okay. So today where all have gone, my dear friends? Where are all? Okay. So now friend, let's see what is equivalent shear. I hope by now you all of you know what is equivalent shear. And what were our principle? We were simply trying to break our, you can say, torsional moment into 2 components. One is which one? One is shear component, another is torsion component. Is it clear? One is shear component and another is torsion component. Is it clear? Okay. So shear component we are going to add in the shear force, and accordingly we will calculate your area of vertical stirrups or shear stirrups, and Longitudinal reinforcement component we are going to add on the bending moment so that we can design our longitudinal reinforcement. So see guys, how do we actually calculate the value of equivalent shear? So I hope you know the value. So equivalent shear force is equal to given shear force in the system plus converted portion of shear force plus converted portion of shear force. And what was the expression for the converted portion of shear force? It is 1.6 Tu over B. And one more thing I have told you, friends. See, we have to calculate tau v u, yeah, tau vu equivalent, which is nothing but vu equivalent upon B into D, and this developed value of shear stress, or you can say this nominal value of shear stress, should not exceed your tau c max. If such is the case, in that particular thing, we need revision. If it's so, then section needs revision. It means section needs revision. Is it clear? Please like the session. Whenever you are entered, please like the session. Okay, it means section needs revision. Okay. Next is step number 2, which is calculation of longitudinal reinforcement. So guys, how do we going to calculate longitudinal reinforcement? Just see. First of all, we will calculate the equivalent moment. How I can calculate the value of equivalent moment? Mu equivalent is equal to mu plus mtu. Okay, mu is equal to mu plus mtu. So this mu is the original value of bending moment, but this mtu is the equivalent value of the bending moment, is the converted value of bending moment, which has been converted from torsion to moment. So like that you can think, and you all of you know this value, that it is equal to Tu over 1.7 within bracket 1 plus D by P. So here I told you one important concept, that no doubt we are going to design, or we are going to obtain the area of steel after this, but there were two cases. Next step is what? We have to calculate now area of steel, isn't it? So this area of steel may be even area of steel on the tensile side, or it may be area of steel on the tensile side as well as on the compression side. Just for example, my dear friend, just listen to me. So there were two cases. Suppose you have obtained the value of mu equivalent, obviously due to the actual component as well as due to the converted component due to the torsion. So let me call it mu, it is mtu. So there were two cases. Just see here. Case number 1, I told you, if mu is greater than m2u, then simply find area of steel. But case number 2, if mu is if less than mtu, then find area of steel for tension and area of steel for compression isn't it? So if mu is greater than mtu, then not an issue. Then we have to find simply area of steel corresponding to the tension side. And how can I get sorry? And how can I get the value of AST here? So this AST can be simply equated with the MOR formula. So here AST will be equal to mu equivalent. Okay, so same 0.87 Fy like that. You can calculate. Okay, so if mu is less than mtu, or you can say if mtu is greater than mu, so yesterday I have tried to explain the logic behind this. If mtu is greater than mu, then we have to calculate one more moment, which is mu2 moment, and it is actually the difference of mtu minus mu. So now I will design my area of steel as well as my area of steel for compression. So now I have to provide area of steel for compression side as well as for tensile side. So just listen, my dear friends. Area of steel for tensile side will be corresponding to mu equivalent, or I can say mu plus mtu, means actual component of bending moment plus the torsional component of bending moment, which are going to add here, and compression area of reinforcement is the function of how much mu2, means axis bending moment. What is mu2? Mu2 is nothing but difference of torsional moment and actual moment. Okay, is it clear to or not? So yesterday I tried to explain the logic. I hope it's clear to you guys. Okay, so let's proceed. Let's proceed. After the calculation of longitudinal reinforcement, now next step was calculation of shear reinforcement, or you can say transverse reinforcement. You already have calculated your equivalent shear. So now the task is to find the area of the shear reinforcement or the shear stirrups corresponding to your VU equivalent. Is it clear or not, guys? So here as well, the Indian standard 456-2000 have given the special provisions to find the spacing of the vertical stirrups or inclined stirrups. So what is the formula? What are the various formulas? I think I have written this. So today we are going to use all such things. So I am writing each and everything at single place. So first one was 0.87. I hope it is visible to you guys. Yes, it is 0.87 Fy ASV, isn't it? So 0.87 Fy ASV D1 divided by Tu over B1 plus Vu, only Vu, not equivalent, okay, over 2.5. So any comment, any doubt? So it is first. Second expression was 0.87. Okay, let me use the another marker here. Second was 0.87 Fy ASV. So guys, before proceeding to the calculation of a spacing, first of all of you have to assume the area of the stirrups. It can be 2-legged 8 mm, or it can be 4-legged 8 mm, it can be 2-legged 10 mm, like that. So depending upon the spacing. So in reality, designer, they do have experience, so they know that how much spacing and diameter must be there. So even if you are doing it for the first time, so you can judge the ASV type of stirrups depending upon the spacing. If spacing is too far, then you can increase the ASV slightly. So you can increase the number of legs, or you can increase the diameter of the bar. Or if the spacing is very less, it means congestion will be there. So in order to reduce the congestion, what you have to do, you have to increase the diameter or number of legs. In earlier case, when spacing was too far, in that case you have to decrease, okay, and here you have to increase the ASV value. Is it clear? So it is tau VU equivalent minus tau C into B. Okay, one more clause was there. Or it is, or 0.87 Fy ASV divided by 0.4 B. So any one you have to use. Okay. Third one was x1. Fourth one was x1 plus y1 by 2. Third one was x1. Fourth one was x1 plus y1 by 4. And fifth one was 300 mm. So guys, these were the 5 ways to calculate spacing, and as per Indian Standard Code, here you have to adopt the least one. Here you have to adopt the least one. Is it clear to everyone? Please ask if it is not clear. Yes guys. Guys, this was the thing which we have completed yesterday. So from here onwards we have to proceed, and yesterday I have told you that what is this D1, what is this X1, Y1, B1, all these things we are going to study today. Okay, or I am going to tell you now. Is it clear to everyone? Tell me. Is it clear to everyone? All of you? I hope it is clear to everyone. No doubt. So please like the session, yaar. Please like the session, all of you. Okay. So what is B1, D1, X1 and Y1? This we are going to check now. Listen to me very carefully now. For this, for make you understand this, I have to draw a cross section. So let me draw it. So see guys, I am cutting the cross section of a beam. So let's say what all are the different type of reinforcement which this concrete can have, this section can have. So it is the width of the beam, let's say capital B, and let's say it is the overall depth of the beam. It is the overall depth of the beam. Is it clear? So there are compression reinforcement as well as tensile reinforcement. So let me draw this compression reinforcement by red. So they may be designed or simply to hold the stirrups, and there are some tensile reinforcement So let's say mm, it's your area of steel on the tension side. It will go like this. Okay. So now when it comes to shear stirrups, so how the things will look like. So here I am going to draw my shear stirrups. So it will touch the all of the bars. Okay, I am trying to redrawing this. Okay, so it's like this. So it is your stirrup. Like this. Yes. So now guys, this dark blue is representing the stirrups, this light blue is representing the area of steel on tension phase, this red one is representing the area of steel on the compression side. Is it clear? So now guys, listen to me. See, this is overall width capital B and it is overall depth capital D. Okay, and from here to here, this is known as effective depth. All of you know, up to the CG, it is known as your effective depth. It is known as your effective depth. Now, what is x1 and what is y1? That we have to see, guys. See, I have to use here the different markers. See, guys. Just see. From the center of this reinforcement, let's say it is the value. From center to center distance of the extreme bar, center to center distance of extreme bar. Okay, so it is actually how much? It is actually how much? This is known as your B1. And similarly, if you are going to calculate extreme distance, then it will be called as D1. It will be called as D1. And apart from this, if you are going to calculate the distance between from center of this vertical stirrup to the center of this vertical stirrups. So this distance is known as x1. And so guys, in this chapter, detailing is very important. Unless you fix the diameter of the steel, size of the stirrups and all, you will not be able to calculate all these stuffs. So how you can remember, this B and D are similar thing. B is horizontal direction and D is in vertical direction. It is the distance between the center to center space of the extreme reinforcement. And what about x1 and y1? It is the distance between the center of the vertical stirrups on the one side to the center of the vertical stirrups to the another side. Okay. So just for example, say if I want to calculate y1, then it will be clear cover up to the top plus half of this dia. So this will be subtracted from top, and from downward as well it is clear cover plus half of the dia. So suppose if this capital D is 1000 and here this clear cover is, let's say, 100, and let's say 2 legged 8 mm stirrup is used, then what is the value of y1? What is the value of y1? So it will be 100, sorry, 1000, overall D is 1000 minus 100 minus 4. Okay, so this is from one side, and similar thing we have to subtract from the other side, minus 100 minus 4. So like that you can calculate the value of y1. And further, if you want to calculate the value of d1 and b1, then again these values are to be reduced, like half of the diameter from bottom, and half of the diameter of the reinforcement, and half of the diameter of the reinforcement. Is it clear? So like that we are going to detail here. Okay. Yes. So you learned that how to calculate the value of B1, D1, X1 and Y1, isn't it? So next task is okay, these are the values which you have to use here. Tu over B1, D1, and X1 plus Y1 by 4. So these four are additional detailing thing which we are studying first time. So that's why I took this much of time to explain you this. Okay. So once again I am reminding you guys, before proceeding to the calculation of shear stirrups, first of all you have to assume the suitable diameter of the tension reinforcement, compression reinforcement, shear stirrups and all. You have to assume something. Okay, then only your B1, D1, X1, Y1 will be crystal clear. Don't worry, we will take a numerical on this. So shear is also clear now. And one more thing, whenever you are going to calculate shear here, so here you are in need of tau c value. So we all know that this tau c is the function of grade of concrete as well as percentage of tensile reinforcement. Kaushik, good morning. बहुत लेट हो भाई आज. Okay. So this is the spacing. Okay. What next? Now the last portion, which is calculation of side face reinforcement. Calculation of side face reinforcement. Guys, this side face reinforcement is to be used at the two faces, at the two sides of the vertical stirrups. Let's say, and why it is provided? It is just provided for the sake of stability. So whenever your torsional movement is there, so IS code is suggesting to use the side face reinforcement for your torsional stability. So there are several conditions. So guys, conditions are, okay, I'm not going to draw it again. So conditions are, listen to me. I'm writing here three values. 450, 750, now listen to me very carefully. So when you actually are in need of side reinforcement, suppose guys, if your beam is subjected to torsion, if your beam is subjected to torsion and the depth of the beam or beam only is between 450 mm and 750 mm. If the depth or overall depth of the beam is between 450 mm and 750 mm, then you have to go for side face reinforcement. Side face reinforcement. Okay. When, if torsion is there, if torsion is present in the system along with shear and bending, if torsional component is there, then we have to go for side face reinforcement. Okay. And how much we have to provide, I'm going to tell you soon. Second case is, if the depth of the beam is greater than 750 mm, if the depth of the beam is greater than 750 mm, and even if torsional reinforcement, even if torsion is not there, so here we have to provide always we have to go for side face reinforcement. Side face reinforcement. Okay. So now this one, and if the depth of the beam is less than 450 mm, so doesn't matter if torsion is acting or not, no need to give side face reinforcement. So side face reinforcement is just giving the stability against the torsion. It is making your RCC cage, your reinforcement cage, more stronger, and it helps us to keep that cage intact whenever it is subjected to torsion. And when the depth of the beam is less than 450 mm, at that particular time guys, due to the spacing criteria and all, we never go for side face reinforcement. Otherwise also, side face reinforcement or the impact of torsion are significant when the depth of the beam is high. Okay, but whenever the depth of the beam is intermediate, what is intermediate between 450 and 750 mm, at that particular point of time, we are going for side face reinforcement only if your beam is subjected to torsion. But whenever our depth of the beam is greater than 750 mm, whenever the depth of the beam is greater than 750 mm guys, at that particular time Doesn't matter if torsion is there or not, we always have to go for side face reinforcement. So what is side face reinforcement? Let me draw it for you guys once again. Not once again, means detailing I am going to show you one more time. So here, this time I will be doing it fast. So it is B, overall B, and it is overall D. So there were several compression reinforcement. Let's say this. And there are several tension reinforcement. Let's say this. 1, 2, 3, let's say 4. Okay. Now what we have studied, we provided these shear stirrups. So what is the color combination? I will use the same. Okay. It is your vertical stirrups, or you can say your shear stirrups. So like this. Okay. So side face reinforcement I am going to show by yellow. So these are basically your side face reinforcement. You can see here it is actually decreasing the effective length, or you can say spacing between two extreme steel bars. So due to this effective length of this bar is reduced, and its, you can say, intactness of the cage is also going to increase. So guys, the one which I have shown you bar is your side face. This is, all of you know, it is your compression reinforcement. This is your compression reinforcement. And this is your tension reinforcement. And apart from this, we also have here the shear stirrup. It is shear reinforcement. So spacing of this shear reinforcement is actually we called as the design of shear. So ASV is not only enough. So spacing with ASV is the complete design for shear. And once again I'm repeating, guys, this is Y1. Similarly, this is X1, and here this is B1, and here it's Y, sorry, not Y, sorry, D1. Is it clear to all? Is it clear? Tell me. And how much we have to provide, and how much do we have to provide shear reinforcement? That is also important. So this, sorry, side face reinforcement. The side face reinforcement, so with yellow I have to write. So the side face reinforcement is how much? So it is denoted by area of steel, and this SF means side face. It is only 0.1% of the effective area. Okay, it is 0.1% of the effective area. Okay. Good morning, Rahul. Om Kapoor, what are you saying? 750 mm is what? Okay, we'll clear your doubt while we will study the question. So this is the side face reinforcement. And one more interesting thing, or you can say interesting fact. Side face reinforcement is always to be provided symmetrically. For example, suppose the 1% of the BD, the 1% of the BD also called as, or 0.1% of web area, area, or effective area you can say, or you can say the effective area. Okay. So suppose if you are calculating 0.1%, and if you are using 0.1%, and you have adopted the 8 mm bar, you have adopted the 8 mm bar, and with that the number of bars are coming 5. So those 5 bars you cannot provide here. You always have to provide symmetrically your side face reinforcement. So if 5 number of bars are coming, then simply you can make it 6, and that 6 is to be divided 3 and 3 on each faces. Okay, so side face reinforcement is always to be provided symmetrically. Is it clear to you? Okay. So rest of the concepts we will learn from this question on the torsion. So guys, see here. Design a beam subjected to following at a particular section with the bending moment 300 kN, shear force 200 kN, and torsion moment 50 kN meter. So guys, we will perform its design here, and this is the overall depth. This is the overall depth. We are going to perform its design here. So first of all, what you have to do, see, open the IS code with you guys. Keep the IS code with you guys. So let me also open in the meantime. So see, again it is here. So guys, start attempting the problem. So we are going to learn many concepts from this question, and whatever kind of doubts you are having, please ask it now. So today all of you are celebrating the Saturday. So very less strength today. Okay. So shall we start, guys? Shall we start? Okay. Guys, there will be many concepts which will be revealed during the solution of this question, you can say. So I am simply proceeding step by step. I am simply proceeding the step by step. So step number 1, calculation of shear, equivalent shear, or you can say equivalent shear. Okay. So you all of you know now how to calculate the equivalent shear. So equivalent shear, VU equivalent is VU plus 1.6 TU over B. Guys, also learn here how to keep the correct units. Many a times you know the formula and all, but you don't know in what units you have to keep your values. So due to that, your question becomes wrong. So see, VU is how much? Shear force is 250 kilonewton, and here we are going to apply, a factored shear force. So a factored shear force is 300. Since in LSM we are going to take the load factor of 1.5 for dead load and live load combination, and nothing has been given about the load combination, so I will assume that these are the consequence due to the due to the dead load and live load only. So I am going to multiply this bending moment, shear force, as well as this torsional moment by 1.5. Then for me, the design loads will be MU is how much? 450 kilonewton. 300 into 1.5, 450 kilonewton. Shear force is how much? 300 kilonewton. And torsional moment is how much? It is 50 into 1.5, 75 kilonewton. So these are the values. So here your VU plus 1.6 TU over V. So let me check what is the value of equivalent shear. Let me check what is the value of equivalent shear. So VU is 300 kilonewton multiplied plus 1.6. What is the actual value of torsional moment? What is the actual value of torsional moment? It is 75 kilonewton meter. So see here the units very carefully. This B is overall width. This B is overall width. So this overall width is how much? So section is 350 mm. So section is, guys, here 350 mm. So it is 0.35 meter. I am going to write, because this meter and this meter will get cancelled and we will get the overall value of V equivalent. Is it clear to you, guys? Tell me. Is it clear to you? All of you? So any doubt to anyone? So please calculate this. Let me open my calculator. Yes. So it is 1.6 1.6 into 75 divided by 0.35 plus 300. Is it right? I don't know. 1.6 into 75 divided by 0.35 plus 300. So overall it is coming 642, which is quite high. Okay, so here it is quite high. So guys, what is next? What is next? We have to check whether this VU equivalent is satisfying the tau Cmax criteria. Means, first of all, we have to calculate the developed value of shear stress due to this VU equivalent, and let's see what is the value of tau V equivalent. So tau V equivalent is equal to simply VU equivalent upon B into D. So VU equivalent is how much? It is 642.85 into 10 to the power 3 Newton. Width of the section is 350 into 750 mm square. So it is actually how much? So 642 so it is 2.44. It is 2.44 Newton per mm square. I think it is quite high. It is okay. One more thing. Now guys, listen to me. This 750 is the overall depth. So mistakenly I have used it here. So here I have to adopt the effective cover. So I am assuming, although it is not given, okay, grades are also not given. So I am assuming cover, effective cover to be 50 mm. Okay, I am assuming cover, effective cover to be 50 mm. Is it clear? And yes, I am going to use here M25 and FE415. So these are the grades which I am going to use here, and effective cover I am going to use 50 mm, and effective cover I am going to use as 50 mm. Is it clear, guys? So next thing, So I have to use here 700. So if 700 is to be used, then what is the value? It will be so guys, please help me. Take out your calculator, all of you. Take out your calculator. Yes, it is 2.62. 2.62 Newton per mm square. Now friend, here the tau V equivalent is 2.62. Okay. And what about tau C max? What about here the value of tau C max? So here tau C max, which is the function of grade of concrete. So it is the function of grade of concrete only. So by looking into the IS code, and referring to table number 20, so all of you can see that here we are safe. So it is 3.1. The value of tau C max from IS code is 3.1. Is it clear? So here you can say that tau C max is 3.1 for M25 grade of concrete. So it means the developed value of shear stress is less than the maximum permissible value of shear stress with reinforcement. So I can say, so it is safe, means it can be designed, means your section do not need revision. Okay. So guys, it's the important question to understanding the concept of torsion. So let's proceed further. We have completed our step number 1, calculation of equivalent shear and the check. So now I am jumping to my second step, which is calculation of longitudinal reinforcement. Calculation of longitudinal reinforcement. Is it clear? So how guys you are going to calculate your longitudinal reinforcement? So first step is to calculate the value of mu. So mu is mu equivalent is mu plus mtu. So mu is how much? Mu is how much? 450, isn't it? Yes. Plus tu is 75. Okay, let me write it with the units. Let me write it with units. It is 450 kilonewton meter plus it is tu, means 75 kilonewton meter upon 1.7. So d is here. Okay. Okay. D was how much? It is overall D, 750 mm, and overall width is 350 mm. Okay. So because it is mu plus your du over 1.7 bracket 1 plus capital D by capital B. So this will give you result in kilonewton meter. So let me check this. How much it is? Please calculate it. I think it is 588.6. So interesting thing is, out of this 588.6, who is dominating? mu. So means in this particular case, you guys do not need second case. You guys do not need your compression reinforcement. Okay. Yes. Good morning, Vibhor. आप सब बंक पे हो भाई, कोई नहीं आया। यही नुकसान है रिकॉर्डेड लेक्चर का, बाद में देख लेंगे। लाइव आने में जो मजा है वो बाद में देखने में नहीं है यार। लाइव आया करो आप लोग। चलिए, so let's proceed further. mu equivalent is 588.65 kilonewton. So next is, here mtu is less than mu, so we will provide is a slightly wrong thing, because we also do provide compression reinforcement there, but that is not to be designed. So we will design is the more appropriate word, tensile reinforcement. Okay, so now it's up to you guys how you are going to evaluate the AST. So how you can find the AST? Step number 2 only. So you guys are having what? mu equivalent, which is 588.65 kilonewton meter. You guys are having grade of concrete, grade of steel, so all such things you to have here. So now the only task is to calculate area of steel. So tell me, how can you calculate the area of steel? So procedure says, first of all equate your bending moment or your moment of resistance with mu equivalent, and from there you can find the value of xu. Then using that value of xu, you will be able to calculate the area of steel from the tension side. So it is the two-step procedure to calculate area of steel. So what I have said, first of all calculate xu by equating your mu equivalent with the factor bending moment, okay, or the maximum moment of resistance, and or simply moment of resistance. From there you guys will get the value of xu. Now corresponding to this value of xu, you guys are going to calculate area of steel, isn't it? Tell me. Okay, so now see, So AST. What I have told? Okay, I am giving you one more approach today. First, what I have told? Calculate mu equivalent is equal to your maximum mu moment of resistance 0.36 FCK B into XU into D minus 0.42 XU. From here, guys, you can calculate XU, and this XU can be substituted in this equation. It can be substituted in this equation. So when you will substitute this value of XU in this equation, so you will get a beautiful expression, which is, so I am telling you, whenever you are going to put this XU from here to here, then you will get AST. It is also a very famous format to calculate area of steel. So first time I am going to tell you this. How you will get it? I have told you, simply put the value of XU from the compression side into the tension side and rearrange the terms. One minus if you can remember this, definitely you guys will be benefited, because it is actually saving your one step. It is actually saving your one step. First of all, you will calculate your XU your XU, and that XU you are going to put it here, and now solve this for area of steel. So this area of steel, when you will solve, you will get this expression. But my dear friend, no doubt it is important, but remember its limitation. It gives correct answer for under reinforced section and limiting section. Just think that over reinforced section is always going to create problem in LSM. So whenever the section is over reinforced, then be extra attentive. Simply I want to say this. So here you can see, suppose if this XU is greater than XU lim, from here only you can check. So you guys know that maximum value of XU is XU lim only. So accordingly area of steel will be calculated. But if you are going to replace here or keep here the actual value of XU, then that value of XU is to be kept here, and it will give you answer accordingly. So actual value of XU is okay only if your section is under reinforced or limiting section. So that's why, guys, this formula to calculate area of steel is beneficial only in case of under reinforced section and limiting section. We are not going to use it for over reinforced section. But my dear friend, remember one more thing. So most of the torsional problem when it comes to design and all, whose sizes are fixed, so that is like your under or limiting case. They will not go generally over reinforced section. So this majority of the times your this formula will be satisfied. Okay. So there is one more way to remember this, or I can say there is one more variation of this. What is that variation? In terms of percentage. It is in terms of percentage. So AST upon BD into 100. So it is your percentage, you can say. Okay. AST upon BD into 100 is what percentage? So this P in percentage is equal to, so BD I have taken there and I have multiplied by 100 here as well as here. So this 0.5 into 100 will become 50. So this is the another format. Similar thing, only here you are writing in terms of percentage. So now we will take the advantage of this formula and we will calculate the area of steel directly. And now we will calculate the area of steel directly. Is it clear, guys? Tell me, to all of you. Is it clear to all of you? Okay. So any doubt? So shall I proceed? So I hope no doubt. Please write in the comment box if you have any doubt. Okay. So where were we? AST. So now guys, you can directly calculate your AST. It is 0.5 FCK upon Fy bracket 1 minus under root 1 minus 4.6 mu equivalent upon FCK BD square into B into D. This is the expression. So guys, please help me in solving this. So AST, tell me how much is the value of AST? Tell me all of you. How much is the value of AST? Please reply. So FCK is 25, 415. So 1 minus under root 1 minus 4.6 and keep mu equivalent in terms of Newton mm because remaining parameter you are going to put in Newton and mm only. So what is the value of mu equivalent? It is 588.65 into 10 raised to the power 6 4.6 mu FCK B D is 700. Okay, into B is 350 into 7. So for me the result is coming approximately 2900. Yes. So it is 2900 point something 0.17. I hope you guys are also getting the same result. It is 2900.17. Here it is point decimal. So now guys, what you can do from here, each of your design will be different because all are having the liberty to choose the diameter of their choices. So in order to maintain the uniformity, so guys, what we are doing, I am fixing the diameter. Let's say we are working with 20 mm dia in case of tension reinforcement. So tell me the number of bars of 20 mm dia. Tell me the number of bars of 20 mm dia. So number of 20 mm dia are how many? It is 2900.17 upon pi by 4 into 20 square. So this is 2900 divided by divided by pi by 4 into d square. Pi by 4 into d square. Okay. So here it is 10 number of bars, 9.23. Here it is 9.23, which is almost 10. So guys, uh, it will be slightly congested to keep 10 number of bars in 350 mm. So you can increase the diameter, let's say from 20 to make it 25, and if you are making it 25, so theoretically that was also right, but simply if you are making it 25, so it is 5.9, almost equals to 6. Yeah, 6 is looking good. So guys, here provide 6 number of provide 6 number of 25 mm dia. So now all of the other calculation like your B1, X1, Y1, D1 are going to depend upon these value, friends. If it is 25 or 20, so like that it is going to depend upon all of these. So this is your tension reinforcement. So compression reinforcement will not be designed here. Compression reinforcement will not be designed here, but still you have to provide that in order to sustain your shear stress and all. So whenever you are providing this 25 mm dia bars, so at the same time you can also provide the 25 mm dia bar on the compression face so that your shear reinforcement can be hanged there or it can be held, isn't it? So any doubt till here, tell me. So guys, not much time is left, so I don't think we will be able to complete this question. So please ask some doubt if you have any. Is it okay? So till now we have seen that 6 number of bars of 25 mm are needed, and simultaneously we are also going to provide 2 bars of 25 mm dia on the compression phase, isn't it? Okay, so no doubt is here. So next step is, which we'll discuss tomorrow, transverse reinforcement. Transverse reinforcement. Guys, today you can attempt the same, you can practice the same, and you know the all these steps. Now what you have to do in the transverse reinforcement calculation, you calculate the value of tau c. And how can you calculate the value of tau c? First of all, the percentage of steel here, tension reinforcement here, and based on the percentage of tension reinforcement and the grade of concrete, you can simply calculate the value of tau c by using IS 456-2000 table number 19. After that, the value of tau c, calculate the value of nominal shear and all, and you can proceed in the similar fashion which I have explained you yesterday as well as today only, isn't it? So I hope no doubt is here. So we will resume the rest of the problem on Monday morning 9:30 onwards. Okay. So I hope no doubt is there till left. So twice I have taught you this. So simply go to the lecture and try to finish these steps by your own, and assume the suitable diameter, wherever it's come to assumption. So in order to make this uniform, okay, I'm fixing the things for you guys. What you can do, tension reinforcement you are providing 25 mm, compression you are also providing 25 mm. So shear stirrups answer will be uniform. Okay, so you are going to tell me the value of shear, spacing of shear by using 2 lakh 8 mm stirrups. Compression steel is not required from design point of view, but from the connection point of view we are going to give here. AST we have already calculated. Now guys, tomorrow you have to tell me, not tomorrow, day after tomorrow, you have to tell me spacing as well as the number of bars of side face reinforcement, and you have to check whether side face reinforcement is really required or not, isn't it? So guys, have a nice day, and it is my subscription code. If any one of you interested for our full-time subscription for our plus module, and Ash is the first 4 digit of my name, Aishwarya, and 10 is simply is my lucky number, you can say, or you can say 10, you can get your 10% discount. Okay, and don't try to keep here 50, 60, 70, 80. Okay, the maximum discount given to you is 10% only, isn't it? So as 10, keep this in your mind. So guys, stay safe, be healthy. So we will meet soon on Monday morning, and don't go outside if it